Hi everyone, this is Rahman, an AIOps engineer with a passion for helping organizations automate their IT operations using AI. In this video, we are going to implement tracing in FastAPI application. But you don't know anything about it? Why do we need tracing? And from where this thing comes? Don't worry, we will build the foundation together. Just hold on. So first of all, we need to understand observability, one of the most crucial components of AIOps. It's often confused with monitoring. And to be fair, that was the case for a long time. But now, observability has emerged as its own field, unlocking new possibilities. So what exactly is it? Observability is the capability to understand the internal state of a system based on the data it generates, like logs, traces, and matrices. Here is an important distinction. Monitoring tells us if something is wrong, while observability helps us understand why it's wrong and why it's happening. That's a game changer. Now imagine combining observability with AI to make it smarter and more proactive. Sounds fascinating, doesn't it? In short, observability goes beyond traditional monitoring by providing deeper context through detailed data. It's not just a programming library, it's a framework and a set of standards to follow. So how does it work? Observability revolves around the three primary data types. The first one is metrics. These are the performance indicators like CPU usage, memory consumption, or request latency. Then we have logs, which are time-stamped records of events, which can be structured or unstructured, often with the helpful metadata. Finally, we have traces. These provide a big picture view of what happens when a request flows through your application. Whether your application is a monolith or a complex mesh of microservices, traces map out the entire journey of a request, giving you essential insights. These data points come together to create a holistic picture of system health, making it possible to identify the root causes of issues, even in highly distributed environments. Now the big question: how do we implement observability? Fortunately, there are tools to help us, and one of the most powerful is OpenTelemetry. OpenTelemetry is a leading open-source framework that standardizes and simplifies observability for modern applications. It unifies the collection of logs, traces, and matrices, the three pillars of observability, allowing developers to monitor performance, identify bottlenecks, and resolve issues across distributed systems. Its flexibility enables seamless integration with popular tools like Jaeger, Prometheus, and Grafana, making it an essential tool for enhancing monitoring and debugging capabilities. Whether you are tracking latency, analyzing logs, or optimizing system health, OpenTelemetry empowers you to ensure reliability and efficiency in your applications. Now, let's roll up our sleeves and dive into a practical implementation. We will set up a basic observability stack for a simple FastAPI application using OpenTelemetry, focusing specifically on request tracing. So here you can see I have set up a very basic FastAPI application. We have to make this tutorial beginners friendly. That's why we start with the very basic thing. Here you can see we have defined a basic database model for items. An item will take an ID, name, and description. Then we have defined a Pythonist schema for that model. Then in the main file, we defined the FastAPI instance and defined the routes to create, read, update, and delete those items. And inside these routes, we are calling the functions from CRUD, where we perform the relative operations on database. And for the sake of simplicity, we are using the SQLite database. Now let's run this app. First, we have to create a virtual environment to make the package installation isolated. Next, we will install the required packages like FastAPI, UVIcorn, databases, and SQL Alchemy. Great, we are good to go. Now we can run this application. So I will say UVIcorn app, which is the module, or you can say the directory. Then .main, which is the main file named main.py, and :app, which is the application instance of FastAPI. There we go. Now we can perform the request. So let me send a post request to create an item. I will open a new terminal, and here we will send the code request. There we are. We have created an item successfully. Let's grab it now. So we will send a GET request. There we are. Now that our application is working, let's move to the fun part and implement OpenTelemetry. So first of all, we have to install some packages like OpenTelemetry API, OpenTelemetry SDK, OpenTelemetry Instrumentation FastAPI, and then OpenTelemetry Exporter Jaeger, because we are going to utilize Jaeger as the exporter to visualize the request tracing. Great. Let's implement that in our application. So first of all, we will import some of the required packages of OpenTelemetry, like trace from OpenTelemetry, Jaeger export from exporter.jaeger.thrift, FastAPI instrumenter from instrumentation.fastapi, then resource from sdk.resources, trace provider from sdk.trace, and batch span processor from sdk.trace.export. Great. Next, we will set up OpenTelemetry. To just save a bit of time, let me paste the code and explain it. There we go. Here, we start by defining a resource which provides metadata about our service, and we name the service as FastAPI CRUD service, which helps us identify it in later monitoring tools. Next, we create a trace provider, which acts as the backbone for all tracing operations, and attach the resource to it. Finally, we set this trace provider as the global default, ensuring all traces use this configuration. Next, to export the traces, we configure the Jaeger exporter, a tool that collects and visualizes trace data. We specify the Jaeger agent's host and port. It's running locally on the default port 6831. We will just set it up in a moment, so don't worry about that. Then, we connect the exporter to the tracer using a batch span processor, which efficiently processes and sends trace data in batches. Finally, we use the FastAPI instrumenter to automatically instrument our FastAPI application. This means OpenTelemetry will now trace all incoming HTTP requests and generate detailed telemetry data without any extra effort. Great. Now that we have configured OpenTelemetry in our FastAPI application, so let's set up Jaeger, the tool that will help us visualize and analyze our traces. And the easiest way to do this is by using Docker. First, ensure you have Docker installed on your system. If not, head over to the Docker's official website and follow the installation guide. It's pretty straightforward. Once Docker is ready, open your terminal and run this command. Here, it will pull the Jaeger all-in-one image from Docker Hub and stores it as a container. The -p flags map various ports from the container to your system, so Jaeger can receive trace data and provide a user interface. The most important port here is 16686. This is where Jaeger's UI will be accessible. I already have the Jaeger Docker image downloaded, so it's quick. But on your system, it may take a while, but not too long. Once the command runs successfully, Jaeger will up and running. To confirm, log into your browser and type localhost:16686. There we go. So we set up the Jaeger and FastAPI application. It's time to see the traces. So let's make some requests in our FastAPI application. Here, first of all, I will make a post request to create a new item. Next, we will make a GET request. And finally, let's make requests to multi-trace routes. Great, we are done. Let's go back to the Jaeger dashboard. If we just refresh this page, and if we see under the service, we can select FastAPI CRUD service. This is the name we configured in OpenTelemetry. Now click on Find Traces to view all the traces Jaeger captured. You will see a list of traces corresponding to the request we just made. Select any trace to drill down into its details. For the post request, you will see spans representing the operations performed, like database queries or business logic. The GET request trace will show its flow through the application. For the multi-trace request, you'll see multiple spans showcasing how Jaeger tracks complex workflows. This visualization is what makes observability so powerful. It gives you a clear view of how requests flow through your application, helping you debug and optimize. And there you have it. With Jaeger and OpenTelemetry, you now have a solid foundation for tracing in your FastAPI application. And that's it for now.